Okay guys, let's try this. So the complex number z has one complex nth root with an argument of 112, another complex nth root with an argument of 172. Given the maximum possible value of n greater than 50, find the argument of z expressed in degrees between 0 and 360. Okay, so we know the complex number z to the 1 over n is equal to r to the 1 over n times cis of theta 0, the initial theta over n, plus 2 pi k over n. So the r doesn't matter at all. We can assume that that's 1. Sorry, I just got a text message. Um, okay. So, yeah, this doesn't matter. So we're saying that theta 0 over n, which is what we're looking for, plus 2 pi k over n, 2 pi k over n is equal to 112, and theta 0 over n plus 2 pi k for n is equal to 172 degrees. I should change 2 pi to 360. So I don't understand what the limitation is. I'm assuming n has to be an integer. So given that n is like incredibly large, then can't n just be like 360? Because then we just have like theta plus k, and then we can get each of the. Yeah, and just, oh, what am I saying? It's less than, not greater than. So less than 50. Okay, so what do we need? There are conditions we need. We need 112n has to be expressed by an offset of 360k plus theta. So what I'm thinking is if we take theta 0 plus 360k is equal to 112n. If we notice, this is 112n, but this is really 112 plus 360k, and I don't know what I'm trying to say. Maybe if we subtract these, this has to be k1, this has to be k2, but if we subtract these, we see it as a difference of 60. So 60 is equal to, these cancel out. I'm taking this one minus this one, so 360 k2 over, it's going to be 360 k2 minus k1 over n. So the difference of k2 and k1 has to, over n times 360 has to equal 60. So divided by 60 on both sides, we get 60 k2 minus k1 is equal to 1 over n. So the difference in what am I trying to say? N has to be divisible by 60 times k1 minus k2. So given this, k1 and k2 have to be like 1/2. k1 minus k2 is like 1/2. Because it has to be less than 50, so this doesn't make any sense. What I think is the key insight here is that it's not just 112, it's 112 mod 30. Mod 360. Maybe we should just try values? Well, it has to divide... N has to divide 360 times k1. So the different factors of 360... because I'm trying to think... No, it can include... man. One works, 2 works, 3 works, 4 works, 5 works, 6 works, 7... You'd have to have 7 up top as well, which would just be 360. So 7 wouldn't... Or, I don't know, I guess 7 would work if you make... Wait, what? If you want to add nothing, make k1 0. So then it doesn't matter. Wait. Add 360 is the same as adding nothing. So 7 does not work. 8... 360 is 4 times... Yeah, okay. 9 works, 10 works, 11 doesn't, 12 does, 13 doesn't. I'm going to cross it out. 12 does, 13 doesn't, 14 does, because k1 can be 2. 15 does. 16, I actually don't know. 360 is 40 times 9. 40 is 5 times 8. So, I mean, I guess k1 can be 2. 16 does, 17 doesn't, 18 doesn't, 18 does, 19 doesn't. Is it just any prime? It's just, so what I'm getting at now is that n can't be prime. N can't be prime. Okay. If we were to look at this graphically, or just imagine it really, it's like this and like this, and we have 112 is going to be right after 90, so it's going to be like right here. A little bit more actually, probably. And 172 is going to be right before 180. And this has a difference of 60 degrees. Now we just need a polygon rotated any amount that can give us this. And a hexagon works, in fact. A hexagon works here. This is 60 degrees. Bam and bam. But also a dodecahedron works. So is it really anything? It's a 6. I saw the sun. Yeah, if we don't care about if we just take the difference between these two, that's like taking the shape and making it like this, where we don't rotate it at all. So that's why this, I guess, this works as well. But, that's besides the point. So, the hexagon works, but also the dodecahedron works. I think it's just any multiple of 6, but also maybe just including the factors 2 and 3. So, like, 360 over n has to be able to sum 260. So 360 over n, where n is equal to 6, we get 60, which works. But also n is equal to 12, we get, so n is equal to 48 works. I think that's probably the highest. If we just do n is equal to 6k, we get 60 over k. And then the highest k is equal to 1 works, k is equal to 2, 12, 3, 18, 4, 24, 6, 5, 36, 36, 7, 42, 8, 48. So n is equal to 48 is our answer. So now we just need to find how much rotated this is to where we have this. So if we take 360 over 48, that's equal to, take out the 6, is 60 over 8. Okay, it doesn't need to be an integer, that's fine. Is equal to 30 over 4. 15 over 2 is equal to 7.5. So 7.5 times 48, does that seem right? 7 times 4 is 280, times 8 is 56, times 0.5, yeah, that seems right. So that's how it's going to be. And we're going to start at 0, then we're going to be point like this. It's going to look like that, where this is a 7.5 degree. So if we are offset by a certain number of degrees, if theta 0 over 48 plus 7.5, ooh, here we have a system of equations. Look at that. No, never mind. Because that is just, there's 3 variables, not 2. I think it might just be 112 mod 7.5. 112 mod 7.5. This is going to be weird because it's a fractional modulo or whatever. Take out 75, we get 25 plus 12 is 37. Take out 30, we get 7. So 7 plus, if we're saying, so we're saying that this needs to be 7, I think. We say 7 plus 7.5k is equal to 112. Let's check. 7.5k is equal to 105. 105 is 70 plus 35. That's not the way to split it up. It's 90 plus 15. That's equal to 2. That's equal to 2 times 3 is 6, is 8. Okay. We're getting close. So now we have theta 0 over 48 is equal to 7. If theta 0 times is equal to 7 times 48, then we're going to want to get this modulo 360, but first let's check. 7 times 48, did I just do this? No. Is 280 plus we get 338, or 330, whoa. Yeah, 336. This seems to be right. Let me check. Wow, this is actually right. I'm surprised I got that right. I think I could have done this so much faster if I just got the shape visualization part in my head better, but I didn't really get that soon enough. But hey, I still got it right, and I'm proud about that. Cool, thank you guys for watching. I'll see you guys tomorrow. Bye.